I just need to find some topic for classes that I give today. And for the first time, I'm streaming on my second YouTube channel, Errichto 2. The last time, on my last boring stream, you might remember that I wondered whether I should stick to just YouTube or Twitch. Kostka suggested that maybe I should create a second YouTube channel for these like less precise streams. Something that, well, most of them I call to just boring streams, boring programming streams. And today we are trying that out. I think the stream will last for 2 hours or so. And most likely you're watching it right now on YouTube after everything, because I didn't even announce this stream in advance. I'm not going to like post it about it on Codeforces or anywhere. In particular, my YouTube channel right now has 0 subscribers. I'm sure that will change just when I announce that it exists. But I'm streaming to both YouTube and Twitch, so I guess we'll see a few people from Twitch. But not many. Maybe I should announce myself on Discord. Yeah, what I'm going to do is just find some algorithm to talk about during classes. Then maybe if I have enough time, I will get back to what I did yesterday, not during a stream, but I just checked out various programs for video editing. For now, I use a free program on Windows, like Windows Movie Editor or something like that, but it's not, like, it doesn't have all the features. On the other hand, all the advanced programs are quite complicated, and I would use only 1% of features. It would be nice to find something in between. Maybe before continuing, let me check if the sound works. 1, 2, 3, 4, 5. Yeah, okay, it works. Yeah, we have 4 people on Twitch now. So shall I announce on Discord or not? It doesn't matter much for me. Maybe later. Hello, Mustafa. What can I talk about? In those classes, most people are on some advanced level already, so it can't be something very easy. On the other hand, I don't have enough time to learn something completely new from 0. I'm now on the English version of Emacs, cpalgorithms.com. There are a lot of Algo there. I wonder if there's anything that I can learn in an hour that would be interesting. Maybe I will just find some cool problems to talk about. Finding connected components, bridges, articulation points, strongly connected components, stuff like that is way too easy for them. Dijkstra, Bellman-Ford. I don't know what this is. Desopo-Pape algorithm. The task is to find the shortest path from the vertex V0 to every other vertex. Sounds like Dijkstra. It will work faster than Dijkstra and Bellman-Ford in most cases, and will also work for negative edges. Interesting. However, not for negative cycles. Yeah, so if there are negative cycles, then the paths are minus infinities. Let's see, I've never heard about this algo. I would say that Dijkstra is fastest. Is there some complexity? The algorithm performs usually quite fast, in most cases even faster than Dijkstra's algorithm. However, there exist cases for which the algorithm takes exponential time. Okay, then it's not something valid. Well, I might still read about that, but In competitive programming, we care about worst case scenario, not best case scenario. Also, I wonder, should I record what I'm doing now? I don't think so. What I'm planning to do, by the way, with this second YouTube channel, or maybe let me on Twitch, I should, in the description, I should give a link to the YouTube video. And are we now live on YouTube? Yes, we are. Awesome. Yeah, 0 people watching, I guess. Is there even here? Where is the number of people? I don't see it. Anyway, here I should modify the description and say that this is the link. Yeah, the other things are fine. Maybe I should add programming tag. Tags, programming, please. I remember that I had to change it like twice to make it refresh, what was a bit stupid. By the way, now with multiple channels, so I had YouTube and Twitch channels. I use them both because many people prefer YouTube and watch me on YouTube later. So for sure I want the stream to exist on YouTube, or at least to be later available. Let's see if the tag is here. But YouTube doesn't support streams well, so new people will not find me on YouTube. YouTube doesn't suggest streams, I think. Only on Twitch there is tab like programming, and there some new people will find me. Okay, programming is here after I change it 3 times. Maybe I should just wait a minute. What did I do? And I was worried about the fact that if I put a lot of stuff on my YouTube Errichto channel, it would hurt my channel. The channel wouldn't be suggested to new people, because it's good if channel is about one thing. For example, short videos on algorithms, and this is my goal with Errichto channel. And on Errichto 2 I will just put everything, all the streams, maybe even a stream where I play some game, like for example Portal. I wanted to play it for a long time, and this is something about puzzles, I guess. So I think it would be fine to put it on that second channel. Or something completely else, random, not really well organized. While I think from long boring streams or even solving some problems, I can take a short thing, interesting thing, and put it on the main channel. But the amount of work I must do before every stream increases, sadly. I need to do something with chats. I need to change settings of my streaming software to stream to that place and this place, and it's annoying. I'm not sure if I will stick with that. The stream that is going right now is an experiment. Also, this is the reason why I didn't announce it on Codeforces and Facebook. Okay, MSTs, minimum spanning trees. This is too easy. Second best minimum spanning tree. Second best minimum spanning tree. So we are finding minimum spanning tree, and then for every edge that is not in the spanning tree, I consider adding that edge, and then on some path I will have to remove the worst one. So that's easy. Flows, I'm not very good in maximum flows. Topological sorting is too easy. Edge vertex connectivity. What does it mean? Edge connectivity is the minimum number of edges that need to be deleted so that the graph G gets disconnected. Is it some kind of a flow? Yeah. This is flow. Tree painting. Some bottom-up DP. Given a tree with n vertices, there are two types of queries. The first one is to paint an edge. The second one is to query the number of colored edges between two vertices. Okay, this is easy. Or maybe not so easy, the code is quite long. There are two types of queries. The first one is to paint an edge. The second one is to query the number of colored edges between two vertices. Sounds like a segment tree where we mark something in a point and ask about, well, a path. We need to find the LCE to reduce each query into two queries that are vertical. Euler tour, yeah, I covered Euler tours with them on this previous lesson. RMQ, heavy light decomposition, longest increasing subsequence. I'm not good in game theory. Scheduling is something very unusual. Okay, there's nothing here that I would want to talk with them about. There are also string algorithms, but I'm not good in string algorithms. Maybe I should do. Let me read through the algebra. Maybe here is something interesting. Factorial modulo P. Well, this is the easy algorithm for factorial modulo P. There is also something in O of square root of P that is extremely hard. Discrete root, primitive root, discrete log. That is quite hard. Maybe I should do that. I remember that I have learned that at one point, but it is complicated and I forgot now. Maybe I have just enough time to learn it again. We will reduce that to discrete logarithm problem, so let's focus on discrete logarithm problem. So we have baby step, giant step. Okay, maybe discrete logarithm is easy to cover. I know that solution. And then what else we have? We have discrete root. That boils down to discrete logarithm. That should be fine. So shall I announce the stream on Discord? I guess it's fine. I will just quickly do that on my laptop on the site. We still have 0 viewers on YouTube. I think that YouTube hides the number of viewers if it's 0. That would be unusual. I'm streaming right now on my new second channel. some quick algo research from Emacs. Okay, done. So let's quickly go through the discrete logarithm algorithm first. If you want to check out this site yourself later, the origin of that is Emacs. I think emacs.ru, not Emacs, maybe 3x. Emacs algorithms. Where is the website? Oh, because it's with the hyphen. e-max.ru. This is the website with all the Russian algos, like all the algo descriptions in Russian. And cpalgorithms.com is English translation of that. It's a good big website, good website with algorithms, with quite advanced algorithms mainly. Okay, the discrete logarithm problem is find all x such that a to the x is equal to b modulo m, where a, b, m are given. A and m are relatively prime. If they are not, then the algorithm described below is incorrect, though it can be modified so that it can work. In this article, we describe the baby step giant step algorithm proposed by Shanks in 1971, which has the time complexity of square root m times log. This algorithm is also known as meet in the middle because it uses the technique of separating tasks in half. Yeah, so we have A. Do I need drawings for that? I guess so. These are drawings from our not yet published video research. New page. This is should I name it in some way? Maybe with date? This is the 17th of April. Let me plug my graphics tablet in. I hope it works. Sometimes it doesn't. Yeah, it does today. Awesome. We are given ABM and we want faster than linearly find which powers of A are equal to B. Given A, B, M, find such X that this is true. Modulo M. Modulo M. And what we do in this algorithm is we are looking for we want to precompute A to the 0, A to the 1, A to the 2, and so on up to A to the K, and we'll choose K to be square root of M. And then we also compute A to 2K, A 3K, and so on. And then every power, like A to 3K plus 5, is a combination of 2. This is some number from this column times some number like that. Want the product to be equal to B, so we will say that for each number here, I compute its modular inverse, and I'm looking in this column whether such an inverse exists. I can use a map to get square root m times log. Also I have log because of modular inversion. Can we avoid that? Yes, we can. I can compute once I can compute 1 over a, so a2 minus 1, and then by multiplying that by itself, I can compute a over a square, 1 over a square, 1 over a cubic, and so on. And I don't need to repeat the modular inversion every time. Then what is the fastest approach here? What I would do is I would compute those. I would compute this column, and I would sort them and go with 2 pointers through them, because sorting is very, very fast. I think it should be faster than hashmap. Hashmap allows us to avoid logarithm in complexity, but I think sorting would be better. Obviously, any number can be represented in this form. Yeah, we take that where n is some pre-selected constant, so they chose n instead of k. Complexity. We can calculate f1 of p in log m using the binary exploitation algorithm. So this is one inversion. What did they call f1? Oh, so they moved b to one side of the equation. They say they made an equation a bit different. I wanted to say that for, let's say, case 20, maybe 10, case 10, this is easier. So a to the 27 I wanted to represent as a to 2 times k times a to 7. What they do is they represent it as a to 3k divided by a to 3, so a to 30 minus 3, and that should be equal to b. So they say a to that something times k is equal to b times a to something, where something is up to square root. Well, k is equal to square root. Why do they say that they need a binary exploitation algorithm? They just need to multiply something. I don't get why do they need that. They don't compute some huge power. One moment, I have a phone. And I'm back. Maybe I will code that to make sure that I understand everything correctly, because if we just want to compute a to some small power, like 1, 2, 3, then we have a to 10. From that we can get a to 20 in one operation, a to 30 in one operation, and so on. I don't get this part. But yeah, I would also sort the values. In the second step, we need to calculate f2 of q. This is a1, this is a2. Maybe they don't understand that when they compute a2, so these values, they at the end they will get a2 dot power, like squared. In the second step of the algorithm, we need to calculate f2 of q for every possible argument and then do a binary search. I think gathering those values and sorting as well would be faster, but I'm not sure. The simplest implementation. They have that. If the following code, the function power mode calculates a to the b modulo m, and the function solve produces a proper solution to the problem. It returns -1 if there is no solution and returns one of the possible solutions otherwise. The resulting discrete logarithm can be big, but you can make it smaller using Euler's theorem. You mean we can take it modulo phi of n? Maybe? Or phi of m? Let's see what it does. I'm now on Windows, not on Linux, so it's a bit inconvenient for me to code anything. And let me just run this online. And in main, let's say we cout solve of what? Let's say we are wondering. I know that 97 is a prime number, so let's see what is 10 to the 28 modulo 97. Oh. Maybe Google can't do those operations. Okay, let's run Wolfram Alpha. I don't like using calculator because then we have to click stuff. I'm not sure. 10 to the 28 modulo 97. That's stupid. Wolfram doesn't understand me. 93. Awesome. So solve. A is 10. Here I put the result 93. And modulo is 97. Let's run. Compilation error. Line 33. I forgot semicolon. Running, and 28. Indeed, I got 28. It could be a different value if multiple values give the same result of 93. And I don't get what they mean with the resulting discrete logarithm can be big. It can't exceed m because they do something with constant that is square root of m. That's a bit strange. In this code we used map from the C++ standard library to store the values of f1. Internally, map uses a red black tree to store values. Yeah, hash map would be faster. Improved implementation. A possible improvement is to get rid of binary experimentation. This can be done by keeping a variable that is multiplied by a each time. Yep, so this is the algorithm I would do, and this is not more complicated. What I don't like in their implementation is this square root of m plus 0. It can get rounded down. This program is not correct. Remember, guys, be careful about using float values. They are dangerous. Here what I would do is I would say that this is square root of m plus half, m plus 0.5. Then it's better. Right now, if just single epsilon goes down, this will be rounded down to what? Like for example, for m equal to 100, maybe you would get 9 instead of 10. Okay, this was the easy part, discrete logarithm. Now let's go to discrete root, which is harder. Now we want to find all x such that x to the k are equal to a modulo m. Modulo m. Oh, here they say n for some reason. And in the previous version, apparently m didn't have to be prime, just co-prime with a, which is fine. Still, the baby step, giant step algorithm should work because we didn't do inversions. We did inversion, but we can do it modulo not prime. The second algorithm didn't have any inversions. Yeah, we avoided that indeed. Okay, so an important point for the first solution was we can completely avoid inversions just by moving something to the other side of the equation. And this is a cool thing to do. Yep. We will solve this problem by reducing it to the previous one, discrete logarithm problem. Let's apply the concept of a primitive root modulo n. The primitive root is if by multiplying 1 by g, by g, by g, and so on, we'll get all the possible values that we will get all values co-prime to n. I thought that this is called the generator. Primitive root, Wikipedia. Do we have Polish version? Pierwiastek pierwotny. Generator modulo. What is the difference? I guess it's a different name. Generator or primitive root, yeah, it's the same thing. Here they say we'll get all the numbers in a group. Well, here they just say about getting all coprime values, but the other article said something about a group where everything has an inversion, so I guess it's the same thing. Okay, let's go through these maths. G is a primitive root model n if and only if for an integer a such that GCD a n is 1, there exists an integer k such that g to the k is a. K is then called the index or discrete logarithm of a to the base g modulo n. Discrete logarithm is just says to which power we have to put g to get a, which makes sense. This is just standard definition of logarithm. This is also called the generator, okay, of the multiplicative group of integers modulo n. In particular, for the case where n is a prime, the powers of prime root runs through all numbers from 1 to n minus 1. And this is the whole group, everything that is coprime with n. Existence. Primitive root modulo n exists if and only if n is 1, 2, or 4, or power of an odd prime number or is twice power of an odd prime number. Let G be a primitive root modulo n. Then we can show that the smallest number k for which g to the k is 1 is equal to phi of n. The reverse is also true. Furthermore, the number of primitive roots modulo n, if there are any, is equal to phi of n. If you don't know, phi is the number of coprime numbers that are smaller than this number. I'm really not good in number theory. For some people this might be obvious, not for me. Let's see the algorithm. A naive algorithm is to consider all numbers in range, check if each one is a primitive root by calculating all its power to see if they are all different. The complexity is g times n, which would be too slow. In this section we propose a faster algorithm using several well-known theorems. We know that if the smallest number k for which that is phi of n, then g is a primitive root. Since for any number a relative to prime to n, we know that a to phi of n is 1. We check if g to some smaller d is not 1. We use Lagrange theorems. Okay, we check just divisors. If g to some power, like if g to 10 is 1, then only we need to check g to 5 and g to 2, only in the divisors. If g to 4 if g to 4 is also 1, then g to 8 would also be 1, and if g to 10 is 1, then also g to 2 would be 1. And something like GCD works here. So a divisor would still be such d that g to the d is 1. I understand that this is a bit hard to get, especially if I don't write down anything, but in a moment I will go to writing down some formulas. And a reminder is that I don't fully understand this algo for now. I'm just trying to find something to show during classes for high school students today, and I'm just learning this algo right now. Factorize phi of n. And prove that in the previous algorithm it is sufficient to consider only the values of d which has the form like that. Okay, so we only check phi of n divided by all the prime numbers that are there. For example, if phi of n is 40, then we will just check 40 divided by 2, so 20, and 40 divided by 5, so 8. Because any other number, any other divisor of 40, like for example 4 or 10, it has some how is it called? It is a divisor of one of these two numbers. If you write down the form of 10 as the product of primes, 10 times 5, then there will be some numbers here among numbers phi of n divided by prime that is like bigger, that is a multiply of this value. Now we have a complete algorithm for finding the primitive root. First find phi of n and factorize it. Then iterate through all numbers g from 1 to n, and for each number, to check if it is a primitive root, we do the following. Calculate g to phi of n divided by p of I. If all the calculated values are different from 1, then g is a primitive root. Running time of this algorithm is answer times log phi of n. This is very ugly in format. Let's try to find it on the original website, Emacs. I don't know Russian. I can read a little bit. But we can just translate the website. Discrete logarithm. Primitive root. Is this the thing? Yep. And here we should have better format. We have O of ans times logarithm of phi of n times log n. Okay, so nothing broke. Just the product sign is changed to a dot. Running time is that. And it is proved that g is O of log to the 6 of p. What is p? I guess the prime number. The following code assumes that the modulo p is a prime number. To make it works for any value of p, we must add calculation of phi of p. And this is something very random, but indeed what we do in this what we always do in this find the root of some number is just try values 1, 2, 3, and I knew that you will find that fast, and I think in practice it turns out better than that. I'm not sure though. We said at the beginning that we'll use the discrete root algorithm, so I thought that there will be some baby step, giant step used. Generator of p. So here we find primitive root. Okay, but we need to also find primitive root. I mean discrete root. Primitive root was an easier thing, and we said we want to find such g that g square, cubic, and so on, it produces all the numbers. Hello, angry turtle. Welcome to the stream. Nice code, which this one? Nothing very strange about it. Maybe this is a bit ugly. Does it come in working condition? I don't get what you're talking about. Does it come in working condition? You mean that we should add something to make it compile? Hello, Mickey. Whoa, suddenly 100 people appeared. And by 100 I mean 3, which is more than previously commented during the whole stream. Okay, we are able to find primitive root. I think that this is I thought that the algorithm for that is easier. We just check 1, 2, and so on. Maybe I will investigate that in a moment. So this is incorrect for not prime p. Mickey rate. And who is Mickey? That's a crazy solution to this issue, to be honest. Okay, who is Mickey? Do I get a lot of compliments? No, I don't. But thank you. Sorry for my chat. No issues, Mickey. The question is your channel related to programming? Software engineering, yep, indeed. Okay. I will check you out later. Thank you for the raid. Though I don't really know much about Twitch. I don't know well how it works, but thank you. What I'm doing right now, it will be. Okay, I stream coding. Hello, Squish. Here's the chat maybe for a moment. Oh no, it's a stupid restream chat. Here's the not refreshed version. If you wonder what I'm doing today is, I didn't even announce the stream in advance. I just said, okay, I need to do something, let me turn the stream on and I can record that. I have classes in 2 hours where I teach programming to people that, students that will go to IOI or just train for National Olympiad. And I needed to find some topic to talk about. I'm like out of ideas. I went to Emacs website, cpalgorithms.com, and I found something that is quite boring in my opinion. I don't like number theory or number theorem. I prefer dynamic programming, ad hoc, geometry, but well, they should learn also something that I don't like. I was surprised there was no notification. Well, if you follow me on Twitch, there should be a notification, right? Do you think I will be good at coding? It's possible, Songer. If your question is for serious, there are some people like for some people there is a correlation between having some kind of illness, sometimes social illness, sometimes something with behavior, and being able to, especially to do maths. I think there are a lot of guys who are good in maths and they have some kind of social disease. I guess different part of mind, of brain works in a different way. So if your question is serious, then my serious answer is yes, maybe. And also, if you know me already, you know that I have a YouTube channel, and today, for the first time, I'm streaming on a second channel that is Errichto 2. And we have 3 subscribers right now. Hooray! You can go subscribe to me. Maybe I will... Well, under the Twitch video, there is a link to this YouTube video. You can go subscribe there. But my main channel is youtube.com/Errichto, and I have a lot of stuff here already, and I just want to push streams to the other channel and to make this one a bit cleaner. In particular, I want to remove some videos from this one, those that are not very interesting on concrete, precise. Maybe I will just keep those 15-minute videos on single topics. Maybe here, for example, Google hashcode to recap. This can stay. And 70% of stuff from this one will be moved to the other channel and removed from this one. The bad thing is that the chat will be removed. The history of chat. Why do you think programming is such a male-dominated industry? Because of social stuff from like tens of years ago, I guess. More boys are brought towards maths, informatics, chess, and even in high school or just in university, you will see much more people that go towards the how is it called? The fields like maths, physics, and so on. This is one explanation that is for sure true. The other possible one is that maybe our brains are different and we have more talent towards different stuff. I'm not sure about that. I didn't read any scientific papers about it, but it's possible. Males and females are different. I'm not sure if there is some more talent, for example, towards maths. And maths is related to programming. I think it's a similar type of skills. I hope I don't upset anyone saying something like that. Okay, questions answered. Now let's get back to the topic. I'd say it's a preference issue, not a talent issue. Talent needs to be found first before you can see it. Yeah, this was my first reason. It's a social thing. If other boys don't, or if other girls don't do programming, then some girl that maybe would be interested in that will not try that. And this slowly changes. I'm sure that it's better now than 50 years ago, or maybe than 10 years ago. 50 years ago, there weren't a lot of computers. So this one will be better, but I don't think it will ever be 50-50 in the industry. Big companies like Google try to make it 50-50 or so. They say that the diversity helps. I'm not sure about that, but some ridiculous stuff happens because of that. Like, it's easier for a woman to get a job in Google. A woman, if Google can hire a man or woman with the same set of skills, they will hire a woman because of the diversity. This doesn't necessarily mean it's sexism against men, if indeed it helps teams to be diverse. And there are some reasons for that. It shouldn't be 50-50. Yeah, I also think so. There's a reason girls don't pick it. And the question is how much is because of social norms. If something is unusual for girls, then girls are less likely to pick it. The question is, if we magically jump to the state with 50-50, then what would happen if we just leave the industry be? Would it get back to 80-20 or not? Should I apply to Google then? Yeah, if you're a female, I don't know by the name, then I guess it will be easier for you than a male with the same skills. I just find it on my own. But still, I think less females try programming. Maybe it's also related to interests. I think many people try coding because they did video gaming. Some people try coding and then they jump to more real programming, and more guys do video gaming. Would love to see your stream more often, Errichto. It's just about my time limitations. I'm a girl, but I don't know if I'm good enough. I just have a degree plus 1 year experience. Applying doesn't hurt much. You can search in the internet for, I don't know, sample coding problems. And you must practice for a coding interview. It's true for everyone. And it isn't that females are just taken to Google with 0 skills. I'm not saying you will get there, but it's about practice and a little bit of talent. Interesting how that is regarded as not sexist against men, because if the reverse occurred, men were always chosen over females in similar skill set situations, the world would be raving about sexism. It's a hard topic. The reason Google and other companies say they give for their choices is that teams are better if they are more diverse. And because of that, they try to get more females, they try to get more non-white males. And I'm not sure if this is a good reason. whether a team that is indeed diverse, I don't know a word, diversity, a team with a lot of diversity, whether it is better in inventing stuff, coding stuff. I think just far in the back end it doesn't matter and shouldn't matter. But maybe when we invent new stuff, when we think about features, when we think how something should be done for users, then it's indeed good to have people from different backgrounds. And because this means more ideas, various ideas. Yeah, I'm also from Perth and Google only in Sydney. I think in Poland we also don't have a lot of Google offices. Or you mean that this disqualifies Google for you? Then there are other companies. Google isn't like saint and much better than other companies. There are also other giants, and for example, I don't want to go to work to Google necessarily, at least for now. I'm pretty sure there are a lot of studies that have shown diversity does not equal better teamwork. And it does not equal for sure, but maybe it helps a little bit. That being said, for sure those companies also try to be inclusive, and that's it. They don't say that openly, but this is, I guess, the real reason. I don't know if the reason they give, the one about diversity meaning more ideas, better teamwork, whether this is true as well. Office job versus remote. I like working with people and being surrounded by people, so I would say office job. That being said, most of my life I did remote, and this is much better in terms of time because I don't have to travel 1 hour to work, and I save a lot of time. I know people that need to go from their home like with more than 1 hour to job, and it wastes your life, I would say. I would not want to for years go to job every day for more than an hour, then get back 1 more hour. I know a guy who, someone from my family, who goes to a gym early in the morning before going to work, because thanks to that he travels through the city at 6 a.m. and there is less traffic at that time, so he doesn't waste so much time. Still, he's exhausted. I don't want such a life. That being said, I like talking with people and having someone. Even if I code, sometimes I run some podcast on YouTube, anything that there will be some sound. I just like it. How did you find remote work? I would prefer remote, but I don't know how to get it. Well, Googling is fine. You can Google anything, and there are job propositions, and some percentage of them is remote. I have a very specific situation because I'm very good in algorithms. I'm very interested in competitive programming, and competitive programming gives me job. I can, for example, create contests on programming. So that's unusual. But in Poland, it's not so unusual to work remotely for some big companies from the West that don't have offices here. And for example, my friend is responsible right now for opening a new office in Poland. He's a programmer, but his company from USA doesn't have an office here. They want to. They first hired some people to work remotely, and now they are opening an office. Working with people and being surrounded by people, smart, very smart. Yeah, I like that. Yep. Any more questions? I like this kind of intermission, but and I feel fine with that because I created that second YouTube channel, and I feel that the first channel should be just focused on one thing, algorithms, and if somebody wants to hang out during a stream, then they should go to my Twitch or the second YouTube channel. I'm not sure if that's a good idea, because I waste time to switch, but I will try that for now. Let's see, maybe. I want to make sure that the link from the description works. So we have, I need to remember to change the description. That's also a thing. Okay, everything seems okay. 4 people watching on YouTube, hooray. 5 subscribers, that's awesome. Yeah, as I said already, this is an experiment, and I didn't even announce that on Codeforces. Cool. Yeah, thank you for questions and for the talk. Now let's get back to the primitive root algorithm, or I mess up the names. Which one was easier? Discrete root. Discrete root is harder. Primitive root is just to find that the G that generates the whole group. Okay, now discrete group. In particular, this will use logarithm algorithm, the discrete logarithm, baby step, giant step. And as I said, this is incorrect. This should be n plus half. Otherwise, it can round down. Let's continue going through this thing. Was I on some different? Oh, we have discrete log here. Oh no, too many stuff. I also must practice multitasking. Believe me, that's hard. On the site I have here 2 monitors. In front of me is what you see. On the side I have monitor with chat and with OBS to just see if everything works, if the stream didn't finish. And on the other side I have my laptop with Twitch and YouTube open to see if there is anything wrong with sound, maybe if there are some internet issues. And it requires a lot. Maybe it would be easier if I just did something simple during a stream, but trying to understand a complicated algorithm isn't simple, and it already requires a big percentage of brain power. And I admire people that indeed are able to do streams and they talk with their audience, where the audience is much more active. There are thousands of people watching them, and still they know what is happening. Okay, let's continue. Which one I already know? Primitive root. This is the easiest one. The one with just in square root. No, this is not the one. Discrete root, discrete logarithm. Discrete logarithm is the easiest one. Okay, it was this one with just baby step, giant step. The other two will try to use it. Now, which one is easier? This one is shorter. Here we want to find that G. And they say try every number and factorize phi of n, phi of p, and try its divisors. This part we can do faster with Ross-Pollard algorithm. It works roughly in n to the 1/4 instead of square root. Here we are finding prime divisors of a number, and then for every number from 2 and so on, we want to check if this is a good generator, and we compute this number to some powers, and we check if that's not a 1. So we know that this number 2 phi of n must be 1 because of Euler's theorem. I would do it that way too. What are you talking about, Angry Turtle? Sorry, when I see a comment like a minute after it happened, I'm not sure what I talked about during a stream. Maybe I should take a look at comments more often. I would do it that way too. I'm not sure what you're talking about. Yes, sir, I already forgot what I was talking about. Okay, that's fine. And now the real algorithm is to find discrete root, to find x such that x to the k is a. And this is some maths stuff. Let's apply the concept of primitive root. You can easily discard the case where a is 0. Okay, let's assume a is not 0. Since we know that n is a prime and any number black can be represented as a power of the primitive root, you can represent the discrete root problem as follows. So x we write down as g to the y. G is such a generator, G is generator, so there exists y such that this is true. Now we have one unknown y, which is a discrete logarithm problem. The solution can be found using baby step, giant step. Okay, having found one solution y0, one of solutions of discrete root problem will be that. Okay, that's easy. Finding all solutions then. Let me see if I understand it correctly. We first find generator G, then find y such that g to the y is equal x. And we skip the case with x equal to 0. We say that the definition of generator G was that g to the 1, 2, and so on, it produces all the possible numbers, in particular number x. We use that baby step, giant step algorithm to find y, this value, and then we have the equation g to the, I'm just putting the value g to this equation. X is g to the y, now to the k is a. What is g to the yk is a. Is not a, is a, yeah, not 0. And we know y. What do we want to find? I got lost. We are looking for x such that this is true. So we are looking now for g. No, g, we know g. So we have the solution. Yeah, g to the y will be the solution. Okay, because this is x. And then the trickier part will be to find all the solutions. There are 20 people watching. I'm positively surprised by that, because the topic is very hard. It requires a lot of maths. While usually my streams are more accessible for a lot of programmers because they are about some algorithms that don't require maths so heavily. finding all solutions from one known solution. Let's recall the fact that a prime root always has order of phi of n. Yep. Therefore, if we add the term phi of n to the exponential, we still get the same value. That's true. Hence, all the solutions are of the form where L is chosen such that the fraction must be an integer. When you see something complicated like that, there are two ways to approach that. Either for a long time look at the equations and slowly understand them, or what is in my opinion much better, try to derive them yourself. If you do that once, it means you understand it and you can do it again. And I already did that a few times here. I looked at the article and I went back here to drawing stuff and analyzing this myself. Okay, we want to find all such y's, such that let's call this value as y0. I want to find all y such that this is true. And this will be my x. Here we have multiplication. This is x. I know that when I write down g to 1, g to 2, also to 0, and so on, it has, how is it called, a period of size phi of n. Phi of n, or p. Maybe p is better because we're talking about a prime number. Well, for p, this is phi of p is equal to just p of 1. So let's keep with n, where n is modulo. And then when we have g of n plus 1, these two are equal values. So what do we have? We have y0 times k. This is one proper exponent. Then I know that also y0 times k plus phi of n is the same thing. Phi is the number of smaller numbers that are comprime with n. G to this power is the same, so still equal to a. Then y0 plus times k plus 2 times that, and so on. And I want to find all such y's that y times k is equal to that, is equal to y0 times k plus something integer times phi of n. What do I get from this? I can say that k times y minus y0 is equal something integer times phi of n. Maybe let's see some example. To simplify stuff, let's assume that this is 0. And then k is 20. Then this is 30. Then what the value of y can be? We have then the condition that phi of n should be a divisor of the left side, because the right side is phi of n times something integer. So y can be 0, then 3, then 6, and so on. For example, for a 3, we have on the left product 20 times 3, which is 60. And how did I get this value? I guess this will be phi of n divided by the GCD of greatest common divisor of k and phi of n. Because k is of course divisible by this greatest common divisor. In this case, the greatest common divisor is 10. And phi divided by GCD tells us in what multiplies of k we must jump. It's not a formal proof, but let's see if the article agrees with me. If something plus phi of n divided by GCD, yeah, okay, they agree. It was, to be honest, more like guessing looking at the example. Let's try to do that more formally. How to do it? Of course, we also have that y0, but y will be y0 plus stuff. I want to say that phi of n divides, so is a divisor of k times y, and I know k and y. Phi of n and k have some common greatest common divisor, let's say z, and I can remove that from both sides, divide this and that by z, because for sure this part is divisible. Now I'm left with some part on the left which is coprime with that. Now the left part is coprime with that, so I must have phi of n divided by z, which is the greatest common divisor, divides y, and I have the thing that I wanted to achieve. Here's a full implementation, including procedures for finding the primitive root, discrete logarithm, and finding and printing all solutions. Okay, after the stream, I will ask maybe on like chat with my friends. I will ask my friends what is the exact complexity of that, of finding the generator. They said that it's log to the 6. I think this is always very fast. And we can find that even for big numbers, but I'm not sure. Okay, I guess I understand the whole thing. I will read the code in a moment. What time is it? Okay, I will stream for maybe half an hour more. We have compute a to the b modulo p. We have GCD, which is unnecessary in C++ because there is function GCD. With 2 underscores, I think, or not. Yeah, we need 2 underscores before that, and it is in C++. Finds the primitive root modulo p. Yep, gather all the primes, and for every possible generator res, check if res to that phi divided by the prime, whether this is equal to 1. Okay, then this program finds all numbers x such that this is true. G is generator. Baby step, giant step, discrete logarithm, algorithm. And for now, all of that works only for prime numbers because we said phi is p minus 1. Maybe I will write down stuff that I should remember. Yeah, it's a good idea. And I wonder whether I know all the names in Polish, the classes are in Polish. I guess this is not a big deal. If I don't know something in Polish, I will just say it in English. Okay. Yeah, I think this will not be an issue. So let's For how do I want to do it? In Google Documents? Yeah, that's fine. I have a log document for everything related to streaming. I will eventually publish that, but not yet. Okay, what do we have? We have or maybe, just maybe, I want to do it in a PDF version so I could share it to them. Yeah, that would be best. Give me one moment. Online LaTeX. I have a website for that, to create LaTeX files, LaTeX PDF files online. I need to log in. New project. This is called what? Discrete root. This was the hardest stuff, right? I'm keeping. I still don't remember which one is which is a bad thing. This is discrete root. Discrete root. In a moment you will also see the file. Okay. I copied something from a previous lesson. Let's modify that. What do we have here? Discrete root. The date will be today, that's fine. And how do I want to make it? With some points or stuff? The easiest thing is discrete logarithm. Maybe a section. How does it look like? Okay, that's fine. And this will be given ABM, and this, all of that is in lat. Well, these are symbols. And M. Find one or all. Find X such that A to the X is equal to B. Let's increase the size. It doesn't allow me. That's inconvenient. Oh, zoom in. Okay, now that's better. Zoom out. Yeah, now it should be better for you. I need to find LaTeX symbol equal modulo. Equif. Instead of equal, I will use equif then. Okay, can I remove that character? I'm not sure what that did. I'm not an expert in LaTeX, so I must Google a lot of stuff. And here I don't see a difference between these two. And this is modulo M. I need a space. What do they propose? New command. Why was mod removed? Undefined control sequence. I messed something up. Maybe there is no mod character. Well, LaTeX modulo character operator. bmod as binary op. I don't think this is what I want, but let's check. Bmod. Okay, that's the thing. And let's put that in brackets. Or pmod, maybe pmod is what I'm looking for. Pmod. Even without brackets. Yeah. That's frustrating in the just in any programming job, that you must Google and experiment a lot, especially when learning something new. I've just spent 2 minutes doing one line. Okay, given a, b, and m, but now I know how to do it. Find x such that this is true, and let k be what, square root of m. What do we do? X can be represented as y times k plus j, where I and j are smaller than k. And everything else, by the way, I can remove. I'm just leaving that to remember the format, because maybe I will use this format. Let k be the square root, the exponent x can be represented as blah blah blah, where this where I and j are up to k. Yep. Pre-compute. Actually, it's better to say that this is minus. This is less or equal, and then the formula, the equation becomes a to the, let's copy that, a to the I times k is equal to b times a to the j. We can compute the value of, for each side of this equation, we can compute all O of k values, all all k possible values and look for matches with maps or sorted vectors by sorting vectors and applying 2 pointers. And this is the whole thing, I guess. Given a, b, and m, find x such that something is true. Let k be square root of m. The exponent x can be represented as that. Maybe I should say that I and j are smaller than k. Not sure. The equation becomes that. For each side, we can compute all k possible values and look for matches with maps or by sorting vectors and applying 2 pointers. The complexity is O of k if we use k, which is equal to O of square root of m, if we avoid, if you use unordered maps, so hash maps, ordered maps, and avoid modulo inversion or exponentation. Unordered isn't a word, this is not either. Exponentation? No, it's okay. No. Exponentation, that's a hard word. Let's say hash maps. Nope. Awesome. That was the first step. The next one is primitive root. And primitive root is such g that this is hard to define. If and only if there exists an integer case such that g is a primitive root, is called a number g is called a primitive root if powers of g they generate all the values coprime to m. Let's stick with modulo that was used previously. And here they use n, here they use m. I don't like that. Let's stick with m. And also I will put links that might be useful. This is href dot link. Where do I want to put it? Emacs article. Is this the word article? Primitive root. A number g is called a primitive root if powers of g not generated, all the values coprime to m. And again, let's put a link, ref, or maybe I can do that in section. Can I? Let's see. Okay. So in brackets, I can put a link. Emacs. Maybe just a link. Yeah, that works fine. Let's copy that and put it here as well, just with a different website link. And I think that looks nice now. It's called a primitive root if powers of G generate all the values coprime to M. That is for every such value A, there exists K such that A to K is congruent to blah blah blah. $1 A to K, not A, G to K is congruent to A modulo M. That is, for every such value A, there exists K such that this is true. Yep. K is then called the index or discrete logarithm. K is then called the discrete logarithm. Do I want to write that? Maybe. This is also called the generator of the multiplicative group of integers modulo n. Existence. I don't want to just rewrite the article. I'm preparing one concise PDF for my students. I'm not sure if I will translate that to Polish maybe before a lesson. But not during a stream. On a stream I prefer to keep everything in English. For there exists case such that okay, K is then here called the discrete logarithm. G, the primitive root exists only for M, doesn't exist for all values M. Maybe without an exclamation mark? Because then it's like factorial. The primitive root doesn't exist for all values M. And what then? The number of primitive roots, if there are any, is equal to that. I think I remember now why the number of phi of n must be big. Phi of n also must be big, right? This is at least n divided by 2, or not? Not really. But still it's quite much. I think because of that we can just check 2, 3 and so on, and we'll quickly get the generator. Algorithm. I can close this website, this one as well. We will check the algorithm is to find the primitive root. We check each value from G, from 2 to N. What do they do? To N including N? Why? They here say up to n-1, and in the code they check up to n, what is strange. Or no, n is phi. Okay, so to n-1. Hey Errichto, I'm a big fan and great thing you're doing at the moment and in general. Thank you a lot. That's nice to hear. Thank you, Zdravko. And we have somebody commenting from YouTube. So I'm a big channel now. I need to add some stuff like links to... I don't even have YouTube description now or a photo. Nothing. Errichto 2. Yeah, 6 subscribers. What do I want to say now? To find the primitive root, you check each value from 2 to n-1. We check, and we can check each value, and for each value we could compute all its powers and see its powers linearly. We could linearly compute all its powers and see if we get all the co-prime values. We get all the values. To make it faster, we just will check those few values. From previous section, we know that if the smallest number k blah 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 is phi of n, then G is a primitive root. This is a very important sentence. To make it faster, we just want to check if the smallest k such that g to k is 1. This was what? Pmod? Equiv 1 Pmod m is the smallest k such that is k is phi of m. And the Euler's theorem says this equation is true for k equal to phi of m. So we just need to check if any smaller k smaller k doesn't gives us 1 as well. It's enough to check divisors of phi of n. Even better, it's enough to check divisors of phi of n, and actually it's enough to check every divisor of form phi of n divided by p, where p is some prime divisor of phi of n, m. In Emacs they used sometimes n, sometimes m, which is stupid. Let's keep using m. Recompile. Actually, I'm a Twitch person, but I follow the link from Discord. Cool. Okay. So I'm streaming on Twitch. Twitch TV/Errichto, if you want to jump there. Let's see what we have. Number g is called a primitive root if powers of g generate all the values coprime to m. That is, for every such value a, there exists k such that this. K is here called the discrete logarithm. The primitive root doesn't exist for all values m. To find the primitive root for each value, we could linearly compute all its powers and see if we get all the values. To make it faster, we just want to check if the smallest k is such that this is that. I need to add brackets. This should be phi of m, or maybe latech phi. Maybe there is some other operator for that. I can add brackets. Or what if I write brackets like that? Phi of m. Phi of m. Let's recompile. Nope, that wasn't enough. So I need to add, how is it called? Curly brackets? Round brackets, I guess. Phi of m. Phi of m. Recompile. Okay, that's it. And the final claim is that this is fast. G is of log the it turns out that we will find such G quickly. The complexity is O of LaTeX complexity symbol. There is some special symbol for big O. Math call O. O of like answer times log of what? Of phi of m times, and why do we have logarithm? Because we need to put something to some power. Okay. Log of m. it turns out that the answer is small if it exists. So the whole thing is quite fast. I can remove that, I don't need it. Maybe answer should be a text. I don't see a difference. Maybe txt. Undefined control sequence. So, just t. txt. Nope. Yeah, text. This should work. I don't know why it doesn't. Sometimes in LaTeX formulas you want to put some word there. Apparently I'm doing something wrong. The complexity is of answer times log times log. It turns out that the answer is small if it exists. So the whole thing is fast. Okay. That was primitive root, and the final thing we want to cover is discrete root. Can I hide this? Okay, now it's better. Maybe let's zoom this in even more then. Discrete root was the hardest algorithm, the one that uses the other two. Again, let's add the link. Discrete root is finding a discrete root is defined as follows, blah blah blah. So given KAM, let's copy what we had here, just it will be slightly different. I don't need so many new lines there. Such all x to the a, what did they use? X to the k is a. So given k, a and n, find x such that blah blah. Did we here? So find any or all. Here also I want to find either any or all x such that this is true. X to the k is a modulo m. Awesome. How do we do it? We solve this problem by reducing to the discrete logarithm. Find g. How to find y? Okay, y was that other thing. Find the discrete logarithm, not the primitive root. Primitive root or generator. Find a generator, primitive root. How do they call it here? Primitive root. Primitive root g. Use what is wrong? Primitive. I wrote privative. Private. Use with baby step, giant step. Oh, I didn't say that this is baby step, giant step. What is important, I want to say this method is called blah blah blah. This method is called baby step, giant step, baby step. I'm not sure about the hyphens and spaces. Baby step, giant step. Meet in the middle, or baby step, giant step. Use find discrete logarithm. Find such y that g to y is not equal, equivalent to what did we have, x, with discrete logarithm algorithm. And then we want to find one answer is x is g to y. What did I refresh? One answer is x equal to g of y, g to y. And the others are with that period. All other answers are of form g to y0 plus I times period, where period is phi of n divided by GCD of k and dot. I don't remember how to use the division. Div? Text division, I mean ratio. Frats, yeah, fraction. I forgot the name. Frac of phi of m divided by GCD of k and phi of m. I think we are done. I wanted to here say c dot as multiplication. Find the primitive for the g. Okay. And closing bracket. And we are done. Let's download the PDF. Let's see how it looks like. Discrete logarithm. Let's see if links work correctly. Discrete logarithm is there. Primitive root, and a discrete root. Awesome. Look for merges with maps or by sorting vectors and applying two pointers. This method is called meet in the middle or baby step giant step. The complexity is that if we use hash maps and avoid modular inversion experimentation. Primitive root. Number g is called a primitive root or generator if powers of g generate all the values coprime to m. That is, for every such value a, there exists k such that this is true. K is here called the discrete logarithm. The primitive root doesn't exist for all values. The sentence is stupid. Not every value m has primitive roots. Not every value m has primitive roots. To find the primitive root, a primitive root, there can be many. For each value from 2 to m minus 1, we could linearly compute all its powers and see if we get all the values. To make it faster, we just want to check if the smallest k is such that this, if maybe if k equal to phi of m is the smallest k such that this is true. This is, I think, easier to read. Let's recompile and download again. Number g is called a primitive root or generator if powers of g generate all the values coprime to m. That is, for every such value a, there exists k such that this. K is here called the discrete logarithm. Not every value m has primitive roots. To find the primitive root, for each value we could linearly compute all its powers and see if we get all the values. To make it faster, we just want to check if k is the smallest case such that this. The English term says that this equation is true for k equal to phi of m, so we just need to check if any smaller k gives us 1 as well. It's enough to check divisors of phi m, and actually it's enough to check every divisor of form phi of m divided by p, where p is some prime divisor of phi of m. The complexity is that it turns out that the answer is small if it exists, so the whole thing is fast. And finally, discrete root. Find any case such that this. One answer is that. All the other answers are of form that. One moment. This is stupid. Find such y that this is true, but we don't know x. Something is wrong. Oh, we rewrite that. Okay. So I made a mistake here. Find the primitive root g. Now I want to say transform the equation from x to let g be a primitive root modulo n. Let let's imagine such y that x to y is g, g to y is x, equif. Transform the equation from g to y to k, equif a, to g to k to y, equif a. We know g to k, so we can find y with the discrete logarithm algorithm. Download, open. Find a primitive for g. Let's imagine such y that this is true. Then here we have g to y. Transfer the equation from g to y to k to g to k to y. We know g to k, so we can find y with the discrete logarithm algorithm. One answer is x to is g to y. All other answers are of form that, where this is true. Okay. Let y0 denote the found value y. Let y0 denote the found value y. All other answers are from that, where blah blah. Okay, I think I'm done. What I will do now is I will ask my friends about that thing with, it turns out that the answer is small. The article said it's log to the 6, but it seems quite bad. It's a big number for modulo being 1 billion or 10 to the 18. But I think it's always just small. At least for values that we use in competitive programming. And I'm done. Thank you all for watching. I will soon start regularly stream on Twitch and this second YouTube channel. Maybe, I think, twice a week, each stream being 6 hours or so. All those streams will be about research on algorithms. But when will I start? I'm not sure. Soon I have holidays and I go to mountains for some hiking with my family. Then maybe when I'm back I will do more stuff for YouTube. Plus, soon there will be hashcode finals, and that means I will go to Dublin. I will be there for the weekend. Hopefully with my team I will fight for the first place. Well, not hopefully, we will fight for the first place. I just hope we'll get it. Thanks all for watching. Subscribe, follow me on Twitch. Facebook, Discord links are in the description, Twitter as well. See ya, bye bye.